Alrighty, so we're just going to go through very quickly on how to use Google Sheets. This might apply to your assignment, it might not. It's up to you whether you wish to use Google Sheets. I think it's a really important tool, and it pops up, this type of skill pops up over and over and over again. So it's really, really important to probably get your head around regardless of whether you're planning on using it for your assignment. So in Google Sheets, I've just created a set of data. It's Australia's population over time. Obviously, similar to what you'll be doing, but not quite exactly the same. So over time, I've got 1955 down to 2020 every 5 years and shown the population growth in millions here. So what I'm going to do, firstly, to create a graph is I'm going to select all my data. So I go down here, I hold shift in. Now it's really important to understand that this can only be done on, the later parts of this can only be done on a computer. The iPad version of Google Sheets will not allow you to do this. You'll be able to insert a graph, do your scatter plot, but everything I do beyond that, you will not be able to do. So, first step is to insert our chart. So we click Insert Chart. Now you can do that on your iPad pretty easily. Use the plus sign. Now line charts look really pretty, but that's not actually what we're looking for. We want to go right down here to scatter plot. So scatter plot's the one we want. I'll square that up so you can see what I'm doing. It's going to be hard to do this. I'll just drop this back a bit. Okay, so we want our scatter plot there. Let's try and tell that. Want our scatter plot. So we click scatter plot and we should get a whole bunch of dots. Population is on the Y, years is on the X. Okay, the year is important that it goes on the X because that is our independent variable. Okay, so with this data here, that shows, we can see there's a bit of a trend going on. Okay, it's increasing over time, but we want to know how it's increasing. So to do a bit more with this, I select my data, I right click or double click depending on your option. You click series, you go to population millions, and up on the side, on the right side here, you'll see you've got all these options. Now I want you to go down on series, all the way down to trend line. Okay, so trend line, and I'll try and make this a little bit thicker. Make it pretty strong. So you can see our line. Okay, I'll change our line to a red colour so it looks a bit different. Okay, so there's our trend line. Now you can see that pretty effectively matches our data, and that over time our graph is increasing. That's pretty cool. So we've done a line of best fit. That's pretty cool, but that's not the real power of this function. So the first thing we can do is we can set, so if you go down to label, if you write in use equation, up here on the red, I'll try and zoom right in on that. Where's my little zoom button? I haven't got a zoom button. Wonder if I can zoom in. Right there on the red, you can see that I've got, oh, it's gone too far, brilliant. You can see I've got my equation, 0.242x plus negative 463. What that's telling me is that every year, Australia's population grows 0.242 million people. X is the number of years, okay, and Y is obviously our population. So I can get that information out of that graph. Now that's pretty cool, okay, but that's not, again, the entire power of this. What we can do beyond that is, let's go back a little bit further, up on this right-hand side, so we're up on the right again. Just to remind where we've gone, so we've clicked series, we're down, we've got line of best fit, trend line, okay, we've got linear, we've picked the colour of our line. We've got the equation there by clicking the use equation button. Now I can click this show R squared. And it gives me an R squared of 0.99. I'll try and zoom in, but I don't know how to do that without destroying everything else. So my R squared value there says 0.99, this value here. Okay, so that's my function, and that's my R squared value right next to it. Now that R squared value tells me how close to my points is that line. An R squared value of 1 is perfect. It tells you that your data is perfectly matching your function. We can see that it's not quite there, but it's pretty close. So that R squared value of 0.99 tells me that my data is very, very close to my trend line, which probably means it's a very good trend line. Okay? That is a really good way of checking your line of best fit. Obviously, to get a good result and to demonstrate your mathematical understanding, just shoving this stuff into Google Sheets isn't going to cut the mustard. But if you're able to use this as a checking point and say this is very close to my line of best fit, that could be a really good way of demonstrating your understanding. It also would allow you to sleep easy knowing that you've got a pretty good function that matches the line of best fit created by the computer model. Okay, so you would still be required to create a line of best fit, create your own line of best fit, calculate your gradient and find your linear equation. Of course, your linear equation takes the form of y equals mx plus c. Okay, so you'd be required to find your own values for that, but that's a really good checking point. Okay, it's something that you can definitely use in this in this class and beyond. Okay, really, really good stuff. Hope that helps. Any questions? Mr. Gunning's the man to talk to.